Hi. So I did a little experiment to identify why everyone says that backend scalable backend system needs Kafka. Uh, so I made a system to break that and fix with Kafka. So the system looks like that. While there is three microservice: order service, inventory service, and email service. Order service. If any customer did a order request, the order service do that order service have two motive to decrease one stocks and do a confirmation email to customer. These two responsibilities are handled by these two microservice, inventory and email, and the communication between those service has usually in HTTP API call, and it's very normal for a early startup. Early stage startup has a traffic request in odd event time, not at once. It's totally fine for that case, but things getting worse when you get a sudden request of 1,000, 5,000, 6,000 of request sudden uh, short span of time. So in that case, the thing will or the order service feels back pressure because inventory service have to do a DB call and email service have to do a third party provider call. They will take a constant time. They can't do they can't resolve more requests in short span of time until unless you make more replicas and in scale like millions of requests are coming in short span of time. The replicas make the number of replicas high. It's not a solution and it's not resolve that scenario also. Let me show you the back pressure and fill you the demo. So here is my K9s and there is two email service, two inventory service, three order service, and I have a load orchestrator which will just nothing but a K6, and this will do simulate number of requests I want to give in a span of time. Let me access that dashboard. So this is the dashboard, and I will do uh, 2 million requests in 5 minutes of time. Let's start run. Ignore this thing. Just they see this cluster URL order service. Now order service getting request. You can see that pull request is coming, and email service also resolving those requests. But see, the order service is feeling back pressure because email service and inventory service is taking time to resolve those requests. But order service getting more requests from front end in that case. In this case, load orchestrator. So it is keep it is not able to handle those requests. So this is why they are going. They already start dies once and started up, and again this thing is happening. Let's show it and see the scenario, enter scenario. This exact thing happens in production. Now we are simulating this thing. See, because the restarts happening. The services are kept dying and restarting. It will be the things will be get more host if I delete one pod of email service, one replicas of email service. Okay, so it started up early. It's, let's make the scenario more host. Like let's make the duration less and number of requests more. And started. So that is the overall scenario happens when the things are not don't go in that way. Your service get more requests and your pods are still kept failing. And after a certain point of time, actually I was there for to show you the crash loop backup actually. So unfortunately it did not happen because it depends on the scenario. So the overall the thing happened that and your dashboard goes stuck and the user experience goes very bad because user neither get a confirmation nor get a transaction acknowledgement. So uh, let's now show something to this in between. This is happening. This thing happened just now. The service was kept crashing. Let's introduce now Kafka in between instant API call. Let's make this thing fire and forget. Order service will make an event of order creation and inventory service email service, and the order service will forget that thing. Then the inventory and email service will consume those event and do process one by one, right? So let's go to code base. In code base, let's go the latest branch or the post Kafka is there. In post Kafka, we are in post Kafka right now. Okay, so let's deploy updated code base at the Kafka is enabled. And we have the Grafana too. Okay, it has no port forward defined. Don't know what's the problem. Okay, so all the services are started. Now let's start the Grafana to see what is happening in behind. That is there. What is that? Okay. I have to put forward this one also. Yeah. So this is the dashboard where there is the number of requests we can see, and it is the thing we should observe. Let me delete this thing. It was the unpassed. Okay. There is something confusing. Yeah. So let's hit 2 million requests, and time limit is 5 minutes as it was at the other service cluster and started. Let me show you the Kafka tool. See, order service is handling 200 requests per second, whereas email service is 15 event per second. Inventory service is 15 event per 20 25 event per second. Both service are handling requests based on the capability it has, whereas other service is can capable to handle 300 requests, 400 requests because it did not wait to to resolve all the in task of email and inventory to send email and uh, decrease the stock. They are doing their work with their own pace. They are making Kafka and the things are resolved. So the pain and the fix is verified. I mean, I feel the pain, then I fix it with Kafka. This is something gives you impact. And if I now stop the API request also, then based on the events already has in Kafka pipeline. Order produced total is that much. The Kafka email Kafka process total is that much. So even though the request of order will come down into, I mean the requests are not invoking order service, but as the Kafka events are already created based on 600 requests per second, so they are doing, they are working on this. That's it. The experiment was successful. Things got verified. Impact is established. Thank you.